newspapers have been around for the longest of times. We are working with a few companies that have newspapers going back almost 200 years. So a lot of that is in either microfilms or stored somewhere in the archive in some basement. And how do you digitize them, and how do you use all the information that is there in those archives is the problem that we started with. And one of the first steps is if we can digitize these newspapers and make that information accessible. So one of the first steps that we have in understanding what is there in the newspaper is being able to understand the different parts of the newspaper. So there is the headline, there is a subheading, there is the text, then there are images, there are infographics, and there are advertisements. These are primarily the major parts in a newspaper. There might be other things like the page heading, and then there's some other graphics and whatnot. But essentially, it is important to be able to understand these different parts before we can just OCR on the article and understand what the article is. So it is important to understand what an article boundary looks like. And also, a simple OCR API will not work on a newspaper scanned image because, and we tried that. If you use something like a Google Vision API to do OCR over this newspaper, it would read the entire paper from left to right and will not respect the columns in the newspaper. So it will start from the first column and go on reading that line across the different columns because it is not designed to read newspapers.
So why does newspaper industry need that? That is the problem.
Correct. So I'll tell you what we are hearing from the industry. What we are hearing from the industry is there are huge content archives sitting in basement somewhere, and the cost to carry is extremely high, right? They have to carry insurance, they have to care for it. If somebody wants to go back and search an archive, it takes them forever to find the right piece of content. And this digitization effort that is going on across the industry is helping them solve a lot of that. So all your archives move online to some digital repository. The content discovery becomes much easier. Let's say somebody wants to go back and search for one specific event in history that happened for some reason. Then they have to go to that basement. There is all sorts of physical security controls that are in place. That you have to search for the right articles. You search for the related articles in subsequent newspapers, and it takes a long time. And this digitization effort is kind of trying to solve all of that. Not only that, the cost of carry of these archives is huge. There was New York Times is a huge success story on Google Cloud, where they digitize a lot of their photo archives. And the reason why they did that was a few years ago there was a huge flood in the New York area, and all their archives were at huge risk of getting lost and destroyed. So those kind of challenges also get resolved when you go after the digitization effort. So digitization is something that all the newspaper companies want to do in order to reduce the cost of carry, in order to make it easier for them to search archives and manage archives and so on. And part of the digitization effort for newspapers specifically, how do they make them searchable and discoverable is what we are trying to solve here. And we're going to get into a demo and show you how we solve this. And Jay is going to explain then what was the actual solution that was there for that demo.
So these are prefetched newspapers, and we have stored images. So these are single-page newspapers, and we have them for different eras, 1820s, 1930s, and such. And say if I just click on one of them, this is going to take me down, and it's going to show me the segmentation result for this paper. And now if we have the bounding boxes, and I can do a simple hover on this, and I can get the bounding boxes, and the label is headline, and I get the OCR as emergence of Omicron in under-vaccinated Africa. And it even detects these things as labels, as these things as images, and the other things as images as well, which are, and it can give you the whole text content if you just hover on this. So this is all indexed, and we have this stored. And I can scroll down. So currently we did not label infographics as such, so it's not picking that thing up. But yeah, even sometimes the confidence of subheadline was not that good, but it did pick up this thing as subheadline, and it gives you the OCR text with this as well.
So this
So
model, this particular model was trained with sample set of newspaper
20.
images that we got. The idea is to understand how to do it, and then obviously we train it on the customer's data. So you train it on sample set, and then you run it on the full set. That's the idea.
So a really cool thing about this thing is that this is only from very few images, like 20 images, and we have this result. And another cool thing is that we did not train the model on images. So it was very recent images, say 2021, and the model can even perform good on, that's the beauty of CNNs. It can perform good on even eras that it has not seen. So if I just go to say 1990s, right? And I select an image from this one. So even in this one, it has never seen this sort of object detection. It's not seen in images of this era, and it says that this label is headline and the OCR text is Bihar strike as stalemate, and this one is a image, and it's again detecting as advertisement as an image, because we label it as such, or it might be getting confused, and like we can get the text content as well. One more good thing if I want to show you guys is this is language independent, because the structure is language independent. So if I pick up a Hindi newspaper, it will do the same for you. So it will give you the text even in Hindi. So if this is headline, so it's going to give you OCR in Hindi. How we took it from inception to implementation. So obviously we did explore about the problem, right? And we found that there aren't any out-of-the-box existing solutions, and there weren't any plug-and-play API solutions. And even if there were, the code for them was not freely available as such. So the solution has to be tailor-made. And what do? We just break it down into a software engineering problem as such, and we provide state-of-the-art scalable solutions for each problem, and then just glue them together, microservice architecture, and use the software engineering best practices for that. Okay, so the first problem that you face is again scale. And if you just have a Fermi estimate for that, there's just a back of the paper calculation. If on a single day you receive one newspaper with 15 pages, and you have say 5 papers as such on a single day, and then again from 5 languages, and even if you do this for just 50 years, you have around 7 million pages. So it's humongous to process this. We talked about the end goal being context-based retrieval. So first we'll have to index all of it, and for after indexing, say we even do that, we achieve that, we segment it, we index it. The other problem is about context, right? So you just cannot simply do a text-based retrieval based on the number of words in the document. So Akansha talked about this in one of our previous tech talks. So if you want, you can check that out. It's on MediaAgility's channel, and it's about semantic image retrieval. So something like if I say, I want images of a person playing football or soccer, and if I just do a simple retrieval or text-based retrieval of articles, all pages where there are persons, all pages where there is football, and all pages where there is playing word mentioned, it would be someone who might be playing guitar. Those might get populated in the output results. That we don't want that, right? Because you expect images of people or articles of people where they are playing football. So this is under focus now, resolution of articles. And we saw in the demo that we did achieve it. So we essentially turned it into a computer vision problem. And the initial challenge we faced was that there were lack of label data. And there weren't heuristics to correlate identified bounding boxes with article content. Thing is, even if you identify these things as text content and text content, how do you relate it that these two belong to under the same headline, right? Even these things are text content. How do you resolve it that this is under the same? When you're going to reconstruct the article, you want a headline, and then a text. Both of these texts belong to this headline. So you have to do some NLP processing post your segmentation. So this is the solution architecture we did define. So suppose you have, and we didn't have a lot of images, right? So suppose you have images in cloud storage. What you can do is you can start with a small set of labeled images, and you can expose a compute engine VM to multiple labelers using some vision annotation tool on that. And even if you don't want to do that, you can directly import images from cloud storage to AutoML Vision. And AutoML Vision itself provides a labeling tool. And then you can do training on that. And you can expose it as a cloud machine learning endpoint. And then if you have an app engine, if your app is running on App Engine and you have a backend running on Cloud Run, which we did, so you can take predictions for that object detection model. So little bit about the labeling part. If you just want like a quick computer vision annotation tool, is quite a famous library or tool, you want to say. Good thing about this is it's also available as a Docker image. So that sort of makes you infrastructure independent. If you have like say 5,000 or 1,000,000 images to label, what you can do is you can just deploy it even on any service, on G-Cloud service, and you can expose it to labelers on that Google Cloud project. Another cool thing about it is it allows management of labels very, at a very granular level. So you can have say 5,000 images on your data set, and you want that person A labels 500 images, you can assign a task like that in CVAT. So even AutoML Vision will allow you to import images directly and label them. We use CVAT, but anyone can import images into create a data set in AutoML Vision. And these would be unlabeled images. You can open up a single image and actually create bounding boxes. We can, and we did actually label them. So this whole thing is labeled as a text content. All of these yellow ones are being labeled as headlines, and then you have images being labeled here as well. So this will also give you, AutoML Vision will also give you live label stats. So if you just go on the main page and you can see label stats. So coolest thing about this is that you can even build a model even with, say, just when each label has just 10 bounding boxes. So if you go back here and you see that we had 20 images, you can even start with as low as 5 images and you can train a model. Once you do that, once you train a model, once you have enough labels for that, you can even train it and evaluate it. And that's also available in AutoML Vision itself. So you can get, as you see, we didn't have enough labels for image or subheadline because we only have 20 images. But for headline and text content, the accuracy is like around 95%. And you have precision and recall scores. Once you're satisfied with it, as a proof of concept, we were, and you can just test and use it and deploy it on a cloud machine learning endpoint. And then once you have an API endpoint, you can just hit it with your front end, which we did.
Now I'm just connecting the dots, right? And to create a better problem statement. If we say that 1926 to 1945, when the country was going through the Great Depression, what people should do and what people should not do with respect to their personal finances as well as the corporate finances. Every expert had an opinion, and that really revolutionized the US financial industry, right?
Right.
If we let's say digitize that, and I'm sure they have already digitized that, right? But by using the ML and AI, if we say that, yeah, let us find out the relevance based on the knowledge graph and educate the financial industry on what was relevant at that time that is still applicable today, what were the lessons that industry and people took at that time that changed the course of the action, right? And then this content is nothing but true facts. These are the facts, these are the figures, these are the images that actually bring the hidden history somewhere that is not accessible to the common people, right?
Yeah,
What
absolutely.
actions can we take from these knowledge sources is important.
Yeah, not only that, Swarraj, to add to that, like if I'm, let's say if I'm running a car company and I want to understand how and what has happened with car companies, if I can get the entire timeline of Ford, entire timeline of GM, entire timeline of Toyota for the last 100 years, and I see
Exactly.
how the stock performed and what was the news, and then the entire context of their history when they hired a new general manager, like there is so much in the news that we can structure.
Absolutely.
Once we have
Absolutely.
digitized it, then we structure all of that, build a rich knowledge graph, and build all these timelines for different industries, different companies, different people, different brands. The whole idea was, how do you extract information from newspapers? What we did was segment newspapers into different sections. Dan ran OCR on it. There is another talk, like Jay mentioned, where what we explain is, once we have that OCR, how do we convert that into a knowledge graph, and how do we implement a semantic search on top of it to make this content discoverable again. Just to give you some idea, right? Imagine this is, let's say, New York Times or LA Times or some other major newspaper, and you have content for the last 150 years, and these are mainstream newspapers that are publishing news for the 150 years. Then you have the entire history of the country in this content that you basically digitize. So if you can build a knowledge graph, you know everything about that country. Now if you it's then it's about how smart your knowledge graph is and how smart of a search you can implement to further get information about any topic. Let's say you want to get the history of a particular sports person or a particular company or a particular city for the last 150 years. Those are the kind of things that you can discover now from the content once you have digitized these newspapers.